In this video, I'll show you how to completely break a LAN switch. We'll use an attack called MAC flooding of type denial of service. This is an extremely easy DOS attack to launch on any Ethernet switch from a Linux machine. Let's dive deeper into this attack and see how it works. Switches maintain a MAC address table that maps individual MAC addresses on the network to the physical ports on the switch. This allows the switch to direct data out of the physical port where the recipient is located. Let's take a look at this image. There is a 3-port switch and a PC connected to each port. To exchange frames between networking devices efficiently, the switch will dynamically construct a MAC address table using the source MAC address of the received frames and the incoming port. In this example, when host 1 or H1 sends a frame, the switch will learn that the MAC address of H1 is connected to port 1 and will map the MAC address of H1 to port 1. This process is called MAC learning. Then, when the switch receives a frame for the destination MAC address of H1, it will forward the frame out of port 1 only, because the MAC of H1 was learned and associated with port 1. On the other hand, when the switch receives a frame for a destination MAC address that is not in its MAC table, it will flood the frame out of all the LAN ports of the same VLAN except for the port that received the frame. Note that the dynamically learned MAC addresses are deleted after the MAC address age value has expired. In many cases, the default value for aging the MAC address is 300 seconds. So if a MAC address is not seen within 300 seconds, it will be deleted from the MAC table. This is basically how a layer 2 switch works. The MAC flooding attack will exploit the vulnerability resulting from the basic operation of a switch. It lies in the fact that the size of the MAC table is limited, and once this table is filled, there will be no space for MAC addresses of new devices that are trying to communicate. Subsequently, the switch will start to act as an Ethernet hub, meaning it will forward traffic to all physical ports. A malicious user can use a packet sniffer like Wireshark to capture sensitive data being transmitted between other computers which would not be accessible when the switch operates normally. Okay, let's exploit the switch. This is the topology I'm going to use. My laptop runs Windows 10 and Kali Linux in a VM. You can also use another Linux distribution like Ubuntu or Linux Mint. The Linux machine is connected directly to a Cisco Catalyst switch using a wired Ethernet connection. If you use the same setup, don't forget to set the VM network in bridged mode so that the Linux machine has access to the physical interface of your laptop. To reproduce this attack, besides a Linux operating system, you need a layer 2 switch. You will connect the Linux machine to the switch using a wired connection. Now, if you don't have available such a physical switch, you can still launch this attack. Just run a Cisco L2IOU image in GNS3 and set up a network connection between the Linux host and the devices that run in GNS3. Something like in this image. Take a look at a previous lecture where I've explained in detail how to do that. The tool I'm gonna use to launch the attack is called macbook, which is part of a package called dsnif. This is its mom page. macbook will flood the switch with hundreds or thousands of Ethernet frames with random source MAC addresses per second. This will fill in the switch's MAC table, thus new MAC addresses cannot be saved, and the switch starts to send all packets to all ports. Moreover, The Mac flooding attack could freeze or make the switch to restart because it will continuously learn new MAC addresses and age the old ones. In fact, the switch CPU utilization will be almost 100% during the attack. Will put the switch under a lot of stress. This is a console connection to the switch, and let's take a look at the switch CPU and the MAC address table before starting the attack. Enable, I'm becoming admin, show process, CPU sorted. And the output is showing us that for the past 5 seconds, the CPU usage was just 4%. And the MAC address table of the switch. Show MAC address table. And we notice that there is only one dynamically learned MAC address on port fast Ethernet 0/1. This is the port to which my laptop is connected. Perfect. Let's start the attack on the switch. The first step is to install this sniff that contains macOff, the tool we are going to use. This package is not already installed in Kali Linux, but it belongs to the standard repositories of both Kali and Ubuntu. So apt install this sniff. I've already installed it, so it's already the newest version. Don't forget that in order to install this sniff and launch the attack, you need a user with root privileges. Okay, this sniff is installed. Let's start macOff. All I need is the name of the outgoing interface, the interface that will be used to flood the switch. I'm running ifconfig, and I notice that the interface is called ETH0. Of course, you can see another name and you should use it accordingly. So macOff -i ETH0. And I'm hitting enter. macOff has started to flood the switch with random MAC addresses at wire speed. Now, let's return to the switch to see the damage we have done. Show MAC address table, count. And we see that the switch has already learned 7,992 MAC addresses. The MAC address table of the switch is already full with thousands of bogus MAC addresses. Just take a look what's here. There are thousands of fake MAC addresses. Let's take another look at the switch CPU utilization. Show process, CPU sorted. And we notice that the CPU utilization for 5 seconds is 66%. The switch is under a lot of stress. Now probably is working as a hub, flooding all frames it receives out of all ports. And if we continue the attack, the switch could simply crash or reboot. I've just shown you how to break this Cisco enterprise switch in just a few seconds using Linux and a common tool like macOff. Keep in mind that this is not a Cisco specific attack, but an attack that could be launched on any switch. In the next lecture, I'll show you what countermeasures you can take as a network administrator to protect your LAN infrastructure. See you again in 2 seconds.